Hello everyone, welcome to Daksh Chemistry. Today we will discuss the previous year question asked in CSIR NET or GATE based on inorganic spectroscopy. So the first question is, the reaction between Pi3PaCl3 and zinc powder gives P3I5 as one of the product. The solution state of P-31 NMR spectrum of P3I5 show a doublet at 98 and a triplet at 102. So, what is the correct structure of P3I5? Observe these all four structures. And which one is the correct option?
See what we have given in this question. It is given that two signals we obtained, one at 98 and one at 102. So observe all four options. In which one we will get two signal? This structure. We get three signal due to these three phosphorus atoms all have different structural environment. In this one we also get three signal. This one also get three signal. In this structure, see, these two phosphorus atoms are equivalent. So we get one signal due to these two phosphorus atom and one due to this phosphorus atom. So our correct option is third one, because two signals give this structure. Next question is, in the P-31 NMR spectrum of a diamagnetic complex, meridional complex, this one, expected number of resonance is, if M is a transition metal and their spin quantum number is 0. Spin is 0. Okay. Correct option is which one? Option given are 1, 3, 2 and 4. So see this one. This is the structure of this meridional complex. PR3, PR3, PR3. These three groups are present on a vertical plane. So these two equatorial PR3 are equivalent, but this one is not equivalent to these two groups. So we will get two signals, one for these two equatorial groups and one for this axial group. So correct option is third one. Two signals we obtained. Next question is, how many signals obtained in HPF3 if J coupling of phosphorus fluorine is higher than J coupling of hydrogen phosphorus, and for P31 spin number is half and for F-19 also half. The given options are 3 doublet, quartet, 2 doublet, 1 doublet, 1 triplet. Now see the molecule. These three fluorine atoms are bounded with phosphorus atom. As J coupling of phosphorus and fluorine is higher than J coupling of hydrogen phosphorus, F couple first. Now see the structure. P combined with two fluorine atom and one hydrogen atom. Firstly, we calculate the signals by this formula, 2ni1 plus 1, 2ni2 plus 1. So this is for fluorine atom, this is for hydrogen atom. 2 fluorine atom, half is the spin number, 1 hydrogen atom, half is the spin number. Total signal we get 6 signals. So as J coupling for phosphorus and fluorine atom is higher than J coupling of hydrogen and phosphorus, so F couples first with phosphorus. As F couple first, our one signal split into 3 signals due to fluorine atom. So it split into 3 signals into triplet. Then again due to hydrogen, each signal split into 2 signals. So we get 3 doublets and 6 signals. So what is our correct option? So our correct answer is 3 doublets. First option. Next question is, assuming J coupling for phosphorus hydrogen is greater than J coupling of phosphorus boron, the expected P-31 NMR spectrum of PH3-BH3 molecule is, if for boron spin number is 3 by 2. So which one is the correct option? At first, see the structure of this molecule, PH3BCl3. Now for phosphorus, 2nI1 plus 1, and for boron, 2nI2 plus 1. We calculate the signals. This one for phosphorus, and as the spin number for boron is 3 by 2 and one molecule of boron is present here, we get 4 signals split again by boron, 4 signals. Then by this one we can observe, we obtain 4 signals first, and these 4 signals are just like this. See, these 2 signals are crossed. Why? Because in these 2 options only 2 signals are given here, but from this 4 options are there. So these 2 options may be correct, and which one of these 2 options? As we know, when we talk about magnetic number for those atoms whose spin is half, they split in according to Pascaline rule, 1:3:3:1. So firstly, signal split into 1:3:3:1, but after that when it split again, then it splits into 1:1:1, because spin number for boron is 3 by 2, and for those molecules whose spin number is 3 by 2, they do not follow Pascaline rule. They split into this ratio. So our signal will split into this, and then this, then this. So our correct option is option 3rd. The next question is, the number of lines shown by the BH3 part of the molecule of PH3-BH3 in the H1 NMR spectrum and B11 NMR spectrum. If spin number for B11 is 3 by 2 and spin number for phosphorus 31 is half. Option givens are 8, 8, 4, 8, 3, 6 and 6, 3. Firstly, we will see the structure of this molecule. 3 phenyl groups are linked with phosphorus atom and 3 hydrogens are linked with boron. So, if we see the spectrum in B11 NMR spectrum, we calculate by this formula 2ni1 plus 1 and 2ni2 plus 1. This one for the 3 hydrogen atoms and half is the spin number for hydrogen, and this one for the phosphorus and half is the spin number for phosphorus. So we will get 8 signals for B11. Then in H1 NMR, hydrogen couples with boron as well as with phosphorus. It showed J coupling with phosphorus. Okay, so this one for one boron atom, 3 by 2 is the spin number, and this one for one phosphorus atom. So we will again get 8 signals. So correct option is option first, 8, 8. Next question is, the number of signals obtained in this molecule at 120 degree minus 120 degree Celsius. A 4 signals, B 7 signals, C 6 signals and D 5 signals. So these three possible structures of these molecules are here. In this one, we see that these two fluorines have same chemical environment. So these two are equivalent and get only one signal. In this we get two signals and in this we also get two signals. So total how many signals are there? 5 signals. So correct option is option D, 5 signals. And see the last question but not least. In F-19 NMR spectrum of F4 at 98 degrees Celsius consists of doublet of doublet, quartet, doublet of triplet and triplet. See the structure of SF4 molecule. These 4 fluorine atoms and 1 lone pair are here. It show CSIR structure. And in this one, if we calculate for this fluorine atom, this equatorial fluorine atom, it show doublet due to this same equatorial atom, and this doublet is again splitted by these two axial fluorine atom. So we get doublet of triplet for this. And again if we see this one, its signal also split due to its axial one into doublet, and doublet signal split by these two equatorial fluorine atom again into triplet. So we will obtain doublet of triplet for both these two fluorine atom, axial or equatorial. So our correct option is doublet of triplet. So B is the correct option. Thank you.